This is a presentation on the paper Who's in Control on Security Risks of Disjointed IoT Device Management Channels by Chris Schroeder. So the overview, the paper investigates the complex security issues that arise when multiple device management channels, or as they refer to them, DMCs, are integrated into Internet of Things, or IoT, devices. DMCs are frameworks that allows users to manage IoT devices through various platforms. Some of them studied in this are Apple HomeKit, Zigbee Z-Wave, and smart speakers. The independent operation of these frameworks often lead to security vulnerabilities due to a lack of coordinated security policies. The study introduces the term chaotic device management, or CODEMA for short, to describe these issues, and presents a novel access control framework, which they call CGuard, to mitigate these security risks. So this figure shows the different IoT control channels. So the various DMC management channels that can control an IoT device. Each DMC operates independently and using different protocols like Z-Wave, Zigbee, Apple HomeKit, and smart speaker interfaces. The application logic layer, or ALL, interacts with different DMC libraries such as HAP, Zigbee, Z-Wave, speaker DMC to handle commands through Wi-Fi, Bluetooth, or Zigbee Z-Wave connections. The figure highlights the complex multi-channel architecture in which IoT devices operate, showcasing how these DMCs connect through hubs and cloud services to user applications, emphasizing the potential for security vulnerabilities due to lack of coordination among these different channels. So the problem statement, the primary issue addressed in the paper is the lack of coordination among the DMCs integrated into a single device. Each DMC functions independently and possesses full control over the device. This can lead to security breaches if their policies are not synchronized. For example, an IoT device that can be managed through both the manufacturer's app and Apple HomeKit might be vulnerable if the DMCs are not aligned in their security protocols. This misalignment allows a malicious actor to use one DMC to bypass the security controls imposed by another. Then this can result in unauthorized access to the device. So the fundamental security issue is termed chaotic device management, as we've discussed, CODEMA. So significant security vulnerabilities in IoT devices due to independent operation of DMZs. And so the goal is addressing CODEMA to ensure secure, coordinated management of IoT devices. Okay, so the solution proposed by the paper is CGuard, a centralized access control framework designed to oversee and manage the accessibility of all DMCs on a device, ensuring that no DMC is left in an insecure state. So the framework comprises three main components. And so this figure depicts the architecture of CGuard, which is, as I just stated, the proposed access control framework. CGuard integrates into the application logic layer all of a IoT device encompassing two main components, channel security and channel monitor. These components interact with policy store to manage the accessibility status of different DMCs, the DMC libraries, manufacturer smart speaker HAP, the few examples we've talked about, Zigbee, Z-Wave, are controlled via CGuard to ensure secure device operation. This centralized management approach ensures that no DMC is left in an insecure state, and it provides a robust solution to enhance IoT security. Okay, so the three components from the framework previously discussed. The first one is Policy Store, maintains the centralized policy that specifies each DMC accessibility status. Channel Switch provides an API and the manufacturer's application logic layer can use to enable or disable third-party DMCs. Channel Monitor offers the Get Channel Status API, allowing the manufacturer's ALL program to monitor the on-off status of each DMC. Okay, so the integration of major DMCs. So CGuard design principles ensure it can be easily integrated into existing IoT devices without requiring changes to third-party DMCs. It allows a fail-safe default principle where all DMCs are closed by default unless explicitly enabled by the user through the manufacturer's app. This approach prevents any DMC from remaining in an insecure state and ensures comprehensive control over the device. The investigation focused on the integration of 4 major third-party DMCs, the ones we've discussed: Apple HomeKit, Zigbee, Z-Wave, and BLE-based smart speaker channels. The study systematically analyzed the security management and policy. The results revealed that these channels are typically disjointed, with their security policies operating independently. This lack of coordination allows for practical exploitation by adversaries. Okay, so now I'm going to go through 3 examples of this. So the first is August Smart Lock. So the August Smart Lock can be managed by the HomeKit framework, SmartThings Hub, and August's own app. If the owner relies solely on one DMC, for example, could be the HomeKit, to manage the device, the other channels remain unprotected and can be exploited by malicious actors. An attacker with temporary access to the home's Wi-Fi, such as an Airbnb guest, could configure each DMC to gain permanent remote control over the device, bypassing the owner's security measure. Okay, the next example, so Philips Hue bulb. So Philips Hue devices include DMCs that can be managed through both Philips Hue Bluetooth app and a Zigbee compatible hub. The MDMC, based on Bluetooth for communication, and Zigbee compatible DMC operate independently, leading to potential security risks. For example, if the owner uses the Zigbee compatible DMC in SmartThings app to manage her devices, and MDMC remains in its default state and can be exploited by anyone within Bluetooth range. iSmartGate garage controller. The iSmartGate garage controller can be managed by both the iSmartGate app and Apple HomeKit. Both DMCs leverage Wi-Fi to connect to the internet, but they operate independently. This independence leaves the NDMC open for user binding, while the HomeKit DMC remains oblivious to any change. A malicious user with access to the home Wi-Fi can use the iSmartGate app to gain unauthorized control over the garage door. Okay, so some user study insight. So the author conducted a user study to understand the real-world feasibility of the Codema attacks. There were 24 participants with IoT devices who configured and used IoT devices in a controlled environment. So key findings. So configuration preferences. Most participants preferred not to configure all DMCs due to the time and complexity involved, leaving unused DMCs in a vulnerable state. Wi-Fi sharing. Many users were willing to share their Wi-Fi and IoT devices with others, such as Airbnb guests or babysitters, increasing the risk of Codema attacks. Security awareness. So participants were generally unaware of the potential risks associated with unused DMCs, indicating a need for better user education and more secure default configurations. Okay, so evaluation of CGuard. So CGuard was evaluated for its usability, performance, and effectiveness in secure channel control. The framework was implemented on a proof of concept smart LED light, which supported multiple DMCs, including HomeKit, Zigbee, and smart speaker channel. The evaluation focused on several key aspects. So usability was the first one. A user study involving 72 participants with diverse backgrounds demonstrated that CGuard was well received. Participants found it easy to use and appreciated the automatic closing of unused DMCs. The study highlighted that users favored the capability to manage DMCs through a single app and valued the security enhancements provided by CGuard. So performance. The performance overhead introduced by CGuard was negligible. The framework used only a small amount of runtime memory and storage and did not significantly impact the device's operation speed. Commands issued from the manufacturer's app to the device were executed with minimal delay comparable to systems without CGuard. Integration effort. And so this is still results of CGuard. So integrating CGuard into IoT devices required minimal effort from manufacturers. The device firmware needed only a few additional lines of code to process commands and invoke CGuard APIs. Similarly, the mobile app required slight modifications to add user interface elements for managing DMCs. So this is a continued slide of results of CGuard effectiveness. CGuard successfully ensured that no DMC was left in an insecure state. It allowed devices to enable or disable DMCs and monitor their status through the manufacturer's app. The framework effectively mitigated Codema risks by closing unused channels and preventing unauthorized access. Okay, some additional findings. So the author also identified several critical insights and challenges associated with DMC management in IoT devices. So disjointed management. So DMCs in mainstream devices are generally designed to operate independently without coordinating security policies. This disjointed weak cross DMC control. Some manufactured DMCs include mechanisms to control third-party DMCs, such as managing network provisioning or user binding. However, these mechanisms are often flawed, leading to insufficient cross-DMC management and leaving devices vulnerable to attack. Attack scenarios. The paper details several attack scenarios exploiting CODEMA vulnerabilities. For instance, an Airbnb guest with temporary access to the home's Wi-Fi could configure an unused DMC to gain permanent control over devices such as smart locks or garage controllers. So back to disjointed management. So DMCs in mainstream devices are generally designed to operate independently without coordinating security policies. This disjointed DMC creates security risks where one DMC is left unmanaged. So the vendor response to these findings. After disclosing their findings, the author received acknowledgments from affected manufacturers. Some vendors have started deploying ad hoc mitigations such as third-party DMCs to off or providing warnings about potential risks. However, these solutions are less systematic and comprehensive than CGuard. So, migration strategies. Given the significant impact of CODEMA on the IoT ecosystem, finding effective mitigation strategies is crucial. The author outlines two primary goals for practical mitigation. Control goal. Provide users with tools to fully control their devices, managing all DMC's accessibility status. This can be achieved by integrating CGuard into the device firmware, allowing centralized control over DMCs without depending on third-party DMCs providers to fix their designs. Usability goal. Ensure that mitigation does not negatively impact usability. Users should be able to choose any DMC supported on a device and manage it easily. CGuard achieves this by following a fail-safe default principle where unused DMCs are automatically closed until explicitly enabled by the user. So CGuard implementation of CGuard involves minimal modifications to the device firmware and mobile app. The key steps include device firmware adding code to all the program to process commands and invoke CGuard APIs for enabling, disabling, and monitoring DMCs. For a mobile app, adding UI switches for toggling third-party DMCs and code logic to handle user actions and communicate with the device. The author demonstrated CGuard on a proof of concept LED light, showing that it can effectively eliminate CODEMA risk and work seamlessly with mainstream DMCs like Apple HomeKit and Amazon Alexa. So future directions. So the paper concludes by advocating for a clean slate design and adoption of standardized across DMC management protocols to address the fundamental causes for CODEMA. Key recommendations include multi-layered and coordinated authorization. Implement multi-level security with some DMCs having higher privilege to coordinate policy, configurations, and resolve conflicts among DMCs. Standardize middleware and interfaces. Design standardized middleware to make different DMCs compatible and interoperable, define standardized software interfaces and protocols to allow different DMCs to exchange user information and access control policies. The user emphasizes the need for collaborative effort among IoT devices, third-party DMC providers, and security researchers to develop comprehensive solutions that enhance the security and usability of IoT systems. So in conclusion, the integration of multiple uncoordinated DMCs in IoT devices introduces significant security vulnerabilities. The proposed solution CGuard provides an effective and practical means to mitigate these risks by enabling centralized control over DMC accessibility. This framework enhances the security of IoT devices without imposing significant usability burdens on users, making it a promising approach for securing the next generation of IoT devices. The author's findings highlight the importance of coordinated security management in multi-DMC environments and lay the groundwork for future research and development in the area. And then the reference was the paper that this presentation is over.